So if 25 is a known side, we don't know what side X is, and we don't know the whole side of this right now. So when there was two missing sides, that's kind of fine to say. So we know that this is 11 right there. So the whole thing would be 22 since the other radius would be 11. Okay, great job seeing that, Ash. So this gives us x squared plus our 22 squared, which is 25 squared. Okay, kind of a tricky one. Hopefully you're seeing it and you're doing okay. So we've got x squared plus 22 squared is
40.
bigger than 40.
What?
Bigger than 144.
244.
484. Close. I appreciate the effort though. Moving that 484 to the other side. We've got 141. Giving me radical 141 as my final answer. If you put that into a calculator, you would get a decimal as 11.9. Yep. All right, so these are both tangent segments. So if I drew in the radius from P to R, what could you say about the angle that just got made right there? Right angle. That's from the first side of the paper. P to T, it's also right angle.
They're the same difference.
Is a rhombus the same thing as a kite?
No.
Same difference.
It's well, I think a baseball diamond's a rhombus. It's technically a square, which a square is a kind of rhombus. Well, anyways, so when you said this, when you said kite, great job. Those are congruent. If I'm telling you it is a kite, what can you say about the outside sides? Do they look congruent? So when you called it a kite, you were right. It is a kite. Those are going to be congruent. So tangent segments from the same external point are congruent. What's the difference? Great, good question. A rhombus would be, well, rhombus has all congruent sides. That's the main difference. Yeah. All right, so we could say that RS, that side length, is congruent to TS. So again, that's what we want to see there. Like I could have a 6 and a 6 and a 4 and a 4. Okay, the radii are congruent. The tangent lines that go to that same point, tangent segments, are going to be congruent as well. Now, if this is 5.6 down there, what can we say about Z? It is unknown. It might be a right angle. It kind of looks like it.
Oh, wait. Is that?
Thank you. So again, 5.6 is on the outside going to the same point. It's tangent. This is also on the outside going to the same point, tangent. So we've got 5.6 right there. So you just go ahead and say that that's also true? I probably should have given you that these make tangent lines because you're kind of assuming, and you guys all know what happens when you assume. And so 13.1 would be there, and then 14 would be the Y as well.
I'm on a roll today.
So again, similar question over here, but we're trying to find the perimeter. Again, probably should have given you that these are all tangent lines because I'm leaving you to assume, and I don't love that. Okay. So if I'm trying to find the whole perimeter of that triangle, I need this purple side. What's that purple side going to be? 7.5. Great job. It's going to match that one right next to it. What's the blue side going to be, this squiggly blue? 13.7. Great job. And these remaining two segments, these orange segments, it's not as straightforward. A lot of people probably want to say 21.5, but what should we do? We should subtract. Yep. 21.5 minus 7.5 gives me 14. Again, both of those together should make 21.5. So what's that make that last orange side? So when you add all those up, that's what we're trying to do here. 14 for that perimeter plus 14 plus 7.5 plus 7.5
I'm good. I'm trying to trust my guy.
And then 13.5 and 13 point. Sorry, 13.7 and 13.7. Adding all those, 70.4 as your perimeter.